In this video, I want to look at the variation of data sets. So I have here 3 data sets that actually all have the same average. The average of this data is 3.5. So it's fairly clear in the first data set, but it's a little bit less clear in the others. But we can see that the way the data spreads out in these sets is quite different. We can see we have a linear spread in the first set of data. All of the points are 1 unit apart. By the way, this is a line plot where the number of dots shows the frequency that a number, the frequency for each number or the number of times that it appears. This one is a little bit more, the second one, call this set 1, set 2, and set 3. For the second set, it's a little bit more clustered around the middle. So it's less spread out. The dots have moved in towards, looks like a lot of them towards the number 4, but in general, they've sort of moved towards the middle, all right? In this way, then the third set, they're sort of away from the middle, okay? It's spread towards the ends. Okay, so if we wanted to talk about variation, we would say the middle set doesn't have as much variation. The numbers are clumped together, all right? The first set, there's a lot of variety in numbers that appear, but they appear very regularly. Whereas in the third set, the numbers are sort of spread down towards the end. It's like as if they're trying to get away from each other. So there's a lot of variation in the values of the data because they tend to be at the extremes of the spectrum. There's not much consistency. You could see that we might want to be able to measure, sort of get a sense of consistency in the data. And if this were, I don't know, we were trying to take free throws, let's say, and we had taken maybe 6 free throws. Set 1 could represent, making the first time maybe I make 1, the second time I make 2, and so on. So it looks like there's a linear pattern there. Perhaps I was making more and more. We don't know that that's actually the order in which it occurred, though. The second player is much more consistent. It seems like he or she makes 4 out of 6 a lot. So that's a much more consistent player, even though the average number of points or baskets is the same. And the last person is very erratic. Sometimes they make a lot. There's some 5s and a 6 in there, but they often only get 1. So that's much more erratic. Variance is what we're going to actually measure. Okay, but it's a measure in the spread of the data. All right, so there's an actual formula for this, okay? Actually, in fact, we're going to go from variance directly to what's called the standard deviation, all right? So if the variance, usually we use the symbol sigma. It's like a little O with a little tail on it. It's a lowercase Greek letter sigma. The variance is sigma squared, and sigma, without being squared, is called the standard deviation. And there's a formula in the book for standard deviation, which is the square root of 1 over n, where n is the number of objects in the set or elements in the sample. I'm going to switch, I always use I equals 1 to n. And then we have x of I minus x with a bar over it. Okay, and that's the formula. Now let's figure out what some of these things are. So n is what's called the sample size. So we have 6 dots in all of these pictures, so the sample size is 6. X with a bar over it means the average value. Okay, now in this formula we do a lot of things. The first thing we do is 1. Find the difference between each individual data point, each individual value, and the average. Okay, so I didn't say this, but the x of i's are the data points, the individual values. Okay, then the second thing is we can see we have a, oh, I left something out of the formula. I left a square. So the second thing is we square the results of 1. Okay, and then what do? We have a summation sign. We add results of 2. Okay, that's what the summation symbol means. All right, and then the fourth thing we do is we divide, excuse me, the result of 2 by the number of data points, okay, the sample size. And then the last thing we do is we take the square root of result of 4. Okay, so that's a lot to have happen. So what I would encourage you to do is actually to make the following table when you're working with data. Okay, this table represents these 5 steps, right? So the first thing you're going to want to do is write down x of I. So for our first data set, it's this easy. It's the actual, the elements of the data set. So the numbers 1, 2, 3, 4, 5, and 6, those 6 values are the individual x values. All right. Now, oh, I guess I left out a step. Okay, so the formula says find the difference between each individual value and the average. All right, so what you need to do is actually total these up first. So under here, I'm going to write the sum of the x of i's. That means add them up. And I already know those add to 21, right? And then I can find the average by taking 21 and dividing by the number in the set, which is 6. So the average is 3.5. Okay, now the next thing you look at I'm now ready for step 1. I need to take all of these individual values and subtract the average from them. So if I start at 1 and subtract 3.5, I have negative 2.5. Then I have negative 1.5. Then I have negative 0.5. Negative, and then I'm sorry, this becomes positive 0.5, and then 1.5 and 2.5. Now you'll notice if you pair them up in a clever fashion, that when you add the individual value, the difference between the individual values and the average, if you were to total those, you would always end up with a total of 0 in this column. Okay. Sometimes because of rounding, when we're dealing with numbers that don't work out so nicely with the average, because of rounding, that might be a small residual number there, but it really ought to be 0 if you found the average based on the numbers. Okay, so then that is step 1 in that column. I'll write a 1 above it. We did step 1. Step 2, we need to square the results. So I'm going to write x of I minus x squared. All right, and so if I do these quickly in my calculator, let me quit. Okay, and I have 2.5 squared. All right, that is 6.25. All right, 1.5 squared is 2.25. 0.5 squared is just 0.25, and then we have repeats, 0.25, 2.25, and 6.25 again. Okay, so that's a completion of step 2. All right, we've squared all of the results. Step 3 says to add them up. So let me just pause the video quickly and I'll add them. When I add those up, I get 17.5 as a result. All right, so that looks like that was step 3. Let me just leave that as I'll put a 3 in a circle there. We've completed step 3. Now we need to divide this result by n. Okay, so this was the sum. Okay, now we're going to divide that by n. So the sum, well, let me just write 17.5. Let me write that more clearly. 17.5 divided by 6. All right, and that gives me 2.917. Just keep it in your calculator though, because then we can see in step 5, I'll just take the square root of that. So second square root of the answer that I just obtained, and I end up with 1.71. So that's my sigma value. I took the square root of what I just had above. This was actually sigma squared up there, sometimes called the variance, and then I have the standard deviation of those numbers. It's 1.71. All right. Now, when we get to set 2, we're expecting the variation to be lower. All right. So we should see a standard deviation value that is smaller so that we could do a comparison. Okay, so we need a numerical value for that. So let's repeat this process for those numbers in set 2, and we ought to see that the value is smaller than 1.7. Okay, so here we go. Okay, so I'm going to write down the numbers, the x of I values. All right, so we call that almost step 0, just recording the numbers. I believe we had a 1, 3, 4, 4, 4, and 5. Okay, if we take the summation of those, I'll just total those down here. That's 21. Therefore, the average is 21 over 6 still, and so that's still 3.5. All right, then in the next step, I have to take x of I minus the average, right? So we'll have negative 2.5, negative 0.5, and then these are all 0.5, 0.5, 0.5, and 1.5. Okay, so you can see that the numbers in that column tend to be a bit smaller. If we add those up, we'll get a 0, but you don't need to add them up because it should always be 0. Okay, so now we need the square of those. Okay, so if I square those, 2.5 squared is 6.25 again. And then this is easy. These are all 0.25, 0.25, 0.25, 0.25, and 1.5. Oh, and this is kind of nice. The 4 in the middle add up to 1. So 2.5. I believe this is going to add up to 8.75 when we add those all up. Okay. So now we have the sum of those squares. Now I need to divide that by n. So 8.75 divided by 6. And we could take the square root of all of that all at once. So we have the sum divided by 6, and we take the square root. So second square root of answer. And I end up with 1.207. Let me just double check that that is correct. As I suspected, there's a slight error in here. I found these before. I forgot to square this last one. So this is when I square 1.5, I get 2.25, and therefore this number here should have been a 9.5. And let me just scribble that out. And when I take the square root of 9.5 over 6, I end up with 1.258 instead of what I had before. Now the key is this is smaller. So the standard deviation of this data set, the set 2, is smaller than the standard deviation of set 1 because the numbers are clumped more towards the middle. All right. It's important to know, so we have a central tendency as finding an average mean, or which is the mean or the median, but we can also talk about how the data spreads out around that mean. And we just found that set 2 had a lower standard deviation than set 1. All right, now set 3, we would expect to have a higher one. And if you follow the same thing, which you will for your homework, I believe that you should end up with set 3 having an answer of 1.979. I entered that into my calculator and then let it do the work for me. That's what I was able to attain. Okay, so that's all we have in this video. You're going to want to look up how to use your calculator to find the standard deviation, because you can see there are so many steps. I already made a mistake, and this only has 6 numbers in the data set. When we look at data sets, we're often going to want to have hundreds or even thousands of numbers in the data set. There is no way that you would want to figure out the standard deviation by hand for a data set that is that large. So you're going to want to use a computational device like your calculator or a computer to do these things for you. And computers and calculators do it very quickly, and they don't make errors. As long as you put the right numbers in, you will end up with the correct answer.